when you
Right.
showed the family,
Okay.
then it was a bow of 4, and I had one and I wanted to wide done it to bow of 4, not as a single thing.
I did that mainly just for ease in terms of actually constructing the thing. It's entirely possible to do it that way, but it would have involved a little bit more trickery.
Because I wonder, you know, if we get to the end of the facade and we haven't got enough to do bow of 4 again, we need to have an individual thing.
There might be issues surrounding that, but for the purposes of getting this looking as it looks, to do what you want to do, that was my kind of challenge. All right, but you know, if you came to me with the problem of building one of those, that's as easy.
Okay.
Yeah. So as I said, the guys made this model, and I decided, well, let's see if we can make it too. So what you're looking at on the screen is not exactly what this is, simply because I haven't adjusted it to make it look like that. But the family itself, you know, what would help is if we turn the lights off. We shut down just these lights. But you can see the actual form, say that one for instance there, the form is in it. So if I edit this, should be the last switch she hits. Yeah, there we go. Thank you. Thanks, Brittany. So if I edit this, you'll see this is a group of 2. Yeah. And in a perfect world, I wanted to make 1, but again, just for ease of parameterization, I didn't want to have to reinvent the world of maths to get negatives working with positives. And you know, I could make 1 and get it to work the other way, but again, in the interest of speed and getting it looks like, I just did it this way. So there's actually 2 panels. I've named them after Emily. There's Emily 1 and Emily 2. Okay. Axis. Give a shit. Right. So essentially, what you're looking at, if I shut down the actual solids that have been generated. Let's do it on my screen. So you can see the actual rig that builds this. So essentially, what it is a loft. Yeah. So you've got these sections. So that's 1, 2, 3, 4. This is an adaptive. I use adaptive components for everything that is bespoke, let's say. And by all accounts, I should be using a curtain wall family for this, but because I'm in an experimental world of what might it be, I use adaptive families with the idea that I might need the adaptive component just in case it changes into something that needs to do other stuff. Whereas if you were to say, right, that's what it's going to be, like in the case of the car park, that's what it's going to be. So you'd go back and you'd say, right, I'm going to model that as a curtain wall, now that I know I've got some sort of fixity in the design process. So essentially what's gone on here, if I zoom in on this guy, sorry, it's not particularly clear, is it? Any way to change that?
Yeah, do you want to change the focus a little bit? Do you think it's a bit blurry?
It is blurry, yeah. We'll just have to muck on. We're getting the click share thing installed in that machine there. She's just trying to, hooray! Just a little bit clearer. It's not entirely clear. So the basis of everything of just this entire world here, ignore everything else. The basis for it is this arrangement of points. Yeah. So essentially what I've built is a box. You see the 4 points? The 4 points are all exactly the same as this one. And what you're looking at is each one of these points is hosted off of that and parameterized off of that. Yeah. So this guy here, for instance, has an offset parameter of a meter, or 1. Yeah, because it's not going to be a meter. Yeah. So that is hosted to, is as a relationship to that. That again has got a parameter on it. And this guy down here has a negative parameter on it. Yeah, so there's a down stand and an up stand world. So the box that I've built, the rig, you'll hear a lot of people talking about parametric rigs. The rig is hosted in that world times 4. So essentially what I've got is I've got a box that can flex and move. And all of the points are in a z-axis constraint. So we can do that. Yeah. So you've got, essentially what I've done is I've built a box that this fits into. Yeah. So that there's defined points in the corners of this panel. Yeah. So really what I've built here is I've just built one of them. Because what you've done is you've got a mirror. So I've built a second one that is the mirror of this, which was a bit lazy because I just wanted to get it working to show you. Because I can make that mirrored just by flicking a parameter point, but I've got to use some maths to do that. So, and on a train, it's a bit hard to think. Okay, so outboard of that, all you're looking at really then is a line that's hosted on the top of the box. So I've got sections through the box. Each one of these points is hosted on that edge of the box, and it's got a parameter. So it's linked into a normalized curve parameter here of 0.66, which is 1/3 of the box. So this is just the way parametric terms you have to think. So I've got a box, I need to divide it in 3 because you've got a zigzag. So this point is at 0.66, this point is at 0.33. Yeah, and ditto the points to make it zigzag like this, if you're following me. Yeah. So this point here, for instance, I think 0.25, because it's in quarters, right? Because you're trying to, it could be in thirds.
Yep.
I chose quarters because it's just a decimal point that's easier to divide, because a 0.66 and 0.32 aren't really a division. Yeah, but a 0.25 is. Yeah, so sorry if this is all sort of mathematical, but this is the way you've got to think when you're building this stuff. Because when this thing pops onto your facade, it has a relationship to, obviously, its top beam and its bottom beam, and then you've got a mathematical division of that grid, of which there's a relationship of that to that to that to that, because you want a symmetry, right? So this point here, the top, that's 0.25. Stop, you're not following me. This point at the bottom is 0.75, because that dimension is 1, right? Thus, this guy here, for instance, has a relationship to, well, the way I've programmed this, because it has to be symmetrical, these 2 points have a relationship to these 2 points. So if I go into the parameter settings, I know this doesn't feel that simple. Believe me, it is once you get your head around it. There's offsets and there's sliders. So the sliders here, 1, 2, 3, 4, subsequently 3B and 4B, but concentrate on 1, 2, 3, 4. They all have relationships. Slider 1 is the top point. Up here.
What relationship they're having? What is their relationship to what's the 75? 0.75 is a relationship to which one? How do I know which one that's the relationship? Is it to 1 or is it to 2?
Number 1 and number 2 are the top 2 points. This is when you get into who built the damn thing and how did they build it.
So slider 1 is that point that's in the middle there.
Slider 1 and slider 2 are arbitrary because you're just looking for a design, right? I've just chosen 0.75 from the start. But because you want a symmetry, you need to have a relationship between this and this and this and this, right? So that there's a symmetry in the design. Therefore, there's a parameter that I've set that says if slider 2 is that, then slider 3 is that. Yeah, and I've added a 0.5, 0.5, but I could make the equation much more complex if I wanted to, but I just wanted to have a relationship so I could, just for the purposes of demo, right? Mm-hmm. So when I move, if I change, like even if I change it in here, hopefully the whole damn world doesn't collapse. If I change this to 0.25, this changes to 0.75. because it's an equation that says slider 2 plus 0.5 equals 0.75. And ditto on the bottom, where I want a relationship between slider 1 and slider 4. So I've said, well, slider 1 minus 0.5 in this instance. So when I move that top, that changes to minus 0.25. And that'll fail because it's gone minus, there's no negatives because it can't go beyond the point. I can make it go on the point, but I'd have to model it differently.
This might be a bit silly, but how do I know what is slider 4 when I'm looking at that? How do I know what's numbered 1, 2, 3? I mean, because the 4 corners aren't sliders, are they? They are your...
Well, really what it is the points. And really what it comes down to, again, is who's modelled what, how. And you've almost got to come in, and if this was me saying, oh, just go look at the model, it'd be kind of useless to you, because you'd have to interrogate exactly what's going on.
Yeah. So how do I know if that's slider 1, 2, 3, or 4?
The only way is if you select it, so you work it out to the point where you know if that moves. You can come in here and say, well, what is that? You select it, and it'll say slider 1. Yeah, and that's the only way about it. Well, believe me, this is a very simple rig.
Can you name them other than slider?
You can call it the top. Believe me, I've tried that too. Okay. On rigs where I've said this is the top point that does that.
Yeah.
It makes sense up to a point, and then it kind of get shit. That's really complicated. But if this is a world of sort of free forming it and kind of going, yeah, that's what I want to do. But you could actually go in, and if you want to do it properly in a curtain wall family, then you could start properly using nomenclatures that are relevant inter-panel as you build. Yeah, and you could have an office standard that would be, well, top bar stuff is this, middle bar stuff is that. But that's a whole other world of complexity. Getting your head around how things like this work is almost the first point. Yeah. So this whole thing, then, as you can see, so if I move that's slider 2, and you see number 3 moves with it.
Yeah.
Moving back, moving forward. So there's a relationship to wherever that point is, that point will go to. Yeah. And you could work out a formula that would probably drive all 4 if you really wanted to. Make it complicated, or not make it complicated, just make it efficient. Yeah. Oops. It will break. Okay. But essentially then what's happened is I've gone in off the basis of all of those points in that whole rig. I've just made loft sections through that, created a form that makes it, so on and so forth. That one, create a form. That one, create a form. Now, whenever you're building stuff like this, it's always best to build it in components. And some people would argue that I should have built every piece of this as a separate panel, yeah, in a separate family. So I would actually make each block here something that I would, each block here that I've just generated. Some people would say I should have made that as a 1, 2, 3, 4, 5, 6, 12 point adaptive family and loaded it as a family. Yeah, well, what lots of people would say is that you think on a component level. You say, right, well, that's going to be a component, or that's going to be a component, that's going to be a component. For me, I just want to build it. I just want to see what it looks like. But some would say that you should really drill it down when you're building this stuff, drill it down to the smallest possible denominator in terms of the component.
Stage of planning, and then the next step would be the construction, which would be single.
You can see how the workflow would form itself up quite quickly. You know, you guys have taken it out, say, in Cavendish to the nth degree, but you can see at a concept level how useful it would be to start building stuff like this as early as possible, so that you can use. It's about efficiency of time. You know, if I build this now, and it's there in Revit, then when you actually come to actually build it as a curtain wall family, you're not guessing. You know, you're sort of going, is that SketchUp, or is that Rhino, or is that plasticine, or is it a mod, or what is it? But doing things like this is all in the name of just efficiency and cutting time to deliver, let's say. So anyway, look, not to harp on too much about it. Obviously load that into a project, which is Emily host in this case. This is it's going to ask me that. not going to let it do that in case it explodes. Back. Right, so this is where I have iterated it. So I actually have 2 panels in another family. So before I even get the project mode, and what I could do again is I could build another family that this would load into, maybe as a long piece of wall, for instance. You know, so it's an iterative thing. And you're not all the time overtaxing the system. What most people will tell you about Revit is the more families you use, the better the model will be. And the bigger the family, the better, and the more components of the family. Just the way Revit loads stuff into its memory. If the whole project is made of families, it'll be a lot better than if it was just a project with lots of walls and lots of components and lots of CAD and stuff plugged into it. It'll be very inefficient. Exactly. So it's components. It's like you build the component, but you're editing the components in a detached way from the main project. So what I did then, let me, for those of you guys who have never seen anything like this before, I'll just load one so you can see it. So here's Emily 1. Ignore the types, I was trying to get it to work and I ran out of time. So literally in comes my component. And this is the adaptive world, because the adaptive points really mean points in any space. There's no constraint on the point. The point can absolutely be whatever you want. So when I bring it in here, it asks me to place it. So I go 1, I go forward them, 2. So I'm just telling Revit how I want it to. Oh, I've lost my mouse. Sorry. 3. Think 4, and it'll generate it. Yeah, so that's hosted it. So what I've got in this family is essentially just 4 points, which are going to be the 4 points that place it on the facade. So all I'll do in the main project is I'll set up a grid, and then I'll load this world onto that grid, which I'll show you in a second. But because I've got a mirror and because I'm lazy, I just built 2. I reset the parameters so that they were negative as opposed to positive. Right, so I'm just creating another one. But you can see as soon as I start putting it in, it's the opposite. I could create types and different equations and all that, and I tried, but the train was coming to an end, so I had to do something. Right, so now you've got your panel, just like that. Yeah. I'm just gonna flick to the project that I've already loaded this into. Here's one I did earlier. So this is loaded in a mass mode. I use mass mode for more or less just as a washing line, stuff like this, because mass mode in project lets you do lots of things. So if I activate mass, just come in and just show mass former floors. Enter that mass. So you'll see, so I've just hidden the category so you can only see this. Right. What you see here is a mass that I've subdivided as a grid, right? So you know, I was just thinking that. So you can see how I load it rather than go away. Just make a new one. So massing and site, in place mass. This mass again is just a fluid world of shapes that you can do anything to. So in the instance of this, I'm just going to say it's the big Broadmarsh car park.
Ground.
A second. Right, interruption. Okay, so I always use reference lines as well. I have a tendency not to use model lines, mainly because model lines for me are just setup lines. I'm sketching model lines, and the big win with reference lines is because I've got something that I can set a work plane to. So if I want to set a work plane, I've actually got something to set a work plane to. And just to demonstrate the difference, obviously with our friend's model line, when I create the form, model line be gone. But it does give me a sort of a nifty world of freeform mass, but I'm a constraints kind of guy, so I always like to have reference planes, and then I'll use the reference plane to chop the mass up as opposed to creating sort of freeform masses. It's just it's a personal preference, but at the same time, reference lines, because you're in project mode, you want to have, you want to think reality, right? It's a building, not a big blob. Use your adaptive points, use your mass families for big blobs if you want to make them. Okay, so just for argument's sake here, I'm going to say what Broadmarsh car park is, and I always parameterize, tendency not to touch one. No real difference beyond this is actually in project mode, and I just find it easier if I'm doing conceptual modeling that I know how big something is. And that's something, I mean, it's kind of, you're in a world of how long is a piece of string. Ideally, yes, I would be loading it. I would make a mass family if I had some kind of surety on what scale of the thing is. But if the Broadmarsh car park decides it has 2 or 3 more bays on it tomorrow, kind of want to be able to do that in project mode in a hurry, as opposed to having to guess what's going on in mass mode. They're exactly the same. It's just, again, some would argue that's very inefficient. Don't put masses in project. That's going to slow the model down. You have 200 of those. It's going to be a nightmare. Whinge. You know, it's along the same lines of many rooms, using rooms to define areas. When you only need a 2D area, don't use the room, because a room is actually a mass in the mind of Revit. You've got 200 of them. That things get a little bit choice. Revit really doesn't like lots of masses in project mode. I think you reach a critical point of about 100 of them, and things start going badly wrong. And it's just Revit. I don't know why. You think Autodesk could fix this stuff, but hey.
Sounds really easy. They can put that massive.
Yeah. Can I let me get through the facade, and then I'll show you something else, right? No, I can show you today. Right. Yeah. So anyway, look, I've built this mass. I've parameterized its height. I'm just going to say the height of Broadmarsh car park is exceptionally big. It's 50 meters.
Yeah, it repeats around that mass.
Spoiler alert.
The big P button. The big P button. I said to the Revit forum one day, I said, "You've never pressed the P button? Why have you never pressed the P button?"
Because I've never been in masses before, and I was looking at it without it being in my macro.
There you go. The P button works in every mode. Generally, it's not just mass level. It's a component iterator, so you can put a component into anything, anywhere, and it'll repeat it. Right, anyway, I'm going to click this magic button here, that's divide surface. Okay, you see it creates a surface. I'm just going to, because what we're looking at essentially are panels running in that direction, I'm going to change U grid to 1, or I can actually change U grid to, we should just go none, because there isn't one. I always use maximum spacing, especially in project mode, because this is reality. We kind of want to know how big our panels are. That's just a top tip when you're creating panels. Create panels roughly to the scale that you're going to put them on the building. Don't ask Revit to turn a 500 by 500 millimeter panel into a 1 mile by 1 mile panel. It's going to fail. So if the building scale is roughly 20 meters, make your panel, you know, somewhere between 10 and 30 meters. Because it will work that way, but it won't work in terms of that's 20 meters and that's 200 meters. Try to run the maths and just get off on this. Okay, so for the purpose of this, I'm going to change that to, I think 3 is what I made it. Yeah, so now I've got 3 meter divisions. And then I'm going to click this little button up here called under surface representation, turn on the nodes. And you see it's made all these little dots, essentially just turning on the connector points of the panel of the grid, because I need something to click my panel to. Yeah. So down here you'll see in generic families, in the big family stack, you'll see Emily House 2 is there. I want to create an instance. And it'll load up my, exactly the same as before. It'll ask me, where do you want to put it? I want to put it there. 1, 2. What it's doing now is it's trying to think, ooh, where the other ones might go. It's throwing them into space, so it's trying to generate something. which I wish it wouldn't. I wish it would just stupidly kind of go, oh, you haven't done it yet, and just think about it. Don't I sound it? Dumb thing. Come on, what are you doing? Whoa. Yeah, I probably shouldn't have zoomed that. Might have made a pretzel. Yeah, it did. You see what it tries to do is it actually did host it. It's not. You can imagine when these things get really complicated how tough it can become. So 1, 2. Walk up with him. 3. Come on, 4. Come on, 4. There we go. Imagine what it's like with 22. Right. Okay, so there's the panel on. Okay. I've set this to a thickness within the family just because I have to give it a thickness, so I just selected one. Yeah, but really what we're interested in is we're interested in this profile. Now it's worth pointing out that as soon as that's on there, you should be able to come in here, change that, and it'll automatically stretch. It might disappear. No. So you'll see that it's hosted on there and it stayed hosted on there. So now when I select it, the big red P illuminates up here called repeat. Click that. Ba-dum. Yeah. Let's create them all the way down. Now one thing to always remember, and to your point, Emily, earlier, just remember that you will have to take a corner at some point. So when you are building these panels, this is why I have a point below. So if I go back to my family, just to, that's why that point is below that point. Yeah, not above that point. If it was above that point, then I'd get a weird kind of bird's beak in the corner. They wouldn't quite join up.
Have you made the panel as well, so it's got a different thickness at the peak to what it has at the back?
That's a parameter that I've put in that has a relationship to that. I can't get into that, but it's.
But there's a way you could make that a uniform thickness.
Oh, absolutely, yeah. I was just again kind of lazy. I haven't done the mathematics to make that absolutely relate to how long that is, but you can. But again, in the world of kind of free form, I just wanted to look like that. I'm a minute. Don't over parameterize something. If you don't have to put a parameter on it, don't put the bloody parameter on it, because someone will have to pick it up at some point in the future and try to figure out what you've done. And if you have 50 parameters on the thing, everyone's going to get really confused. If you have 4, it's fine.
We're going to have to see this in plan, so we're going to have to see that it's doing that shape anyway.
Yeah.
So for the sake of that, we would put a parameter on it to make sure that it's the same.
Yeah, yeah. So you probably would have to have some sort of understanding of the universal sort of relationship of an angle.
Yeah, sure.
You're actually determining an offset on something that's being placed vertically.
Absolutely, yeah.
Because Revit always thinks perpendicular wise, and you can set it up on angles and all of that stuff, but someone ultimately is going to have to make that panel and hang it in a perpendicular fashion. They're not going to make something that's kind of a tetrahedron in plan. It's just it's not going to work. Anyway, that's the panel in place, and then it's literally just a matter of going around doing exactly the same thing. Yeah. I won't do one more time, but you get the idea. Yeah. So.
That's the panel builder. Can that be done as a full neck, and can that be then changed into a family, and then connected with a few people?
No, because what you're looking at here is you're looking at something that is kind of, yes, you can build it and form it, but you can't do it like this. What I've built there is something that the best thing about that, you see, is I can put that on almost any building. I've built it once now. So when you come along to me with the next office facade that you might need that needs to look kind of funky, that's been built to more or less mount onto anything that's got 4 points on a grid.
Does the format generate a mass or not? you know, when you import it into Revit. So Rudy's mass would come in. When you click on the face of it, divide.
Yes, exactly. Yeah, you
Yeah.
could see format is a much more fluid world. This is parametric modeling, the kind of hard edge of parametric modeling. And parametric modeling is all about adaptability through mathematics. So this is built, as you can see, as I've gone through the process. That's divided by that, subdivided by that. That relates to that. That does this. So yes, it's free-form modeling, but with constraints. And the great thing with format is that format is just make it look like that. Be fine, you know, and which is cool, and means you can come into this world, and I can trace over it with something like this to make it work. You see, but the thing with format is that it's stable object coming in from a program that is designed to come into this.
You can build that shape, but bring it into Revit, but you wouldn't be able to stretch.
You wouldn't be able to adapt it.
So if you know what the size is, you can build it in format and you bring it in and it stays that size.
Yeah, I mean, you could sloppily build that in format quite easily. But you see, I don't think I would. I would choose to do it this way because this has got longevity. Because this is a single option on a single building. But I built a panel that when Korea calls up and says, give us a skyscraper that looks like that, you actually can. Yeah, and you can use this again, and I don't have to go back to something in format and just try and draw something different. You know, so this is just about reusability. And I've got a mountain of these things.
What that does is you obviously can alter that to 125, I think, go back into the program, tweak it, and re-import it. That does it all.
Because what will happen is someone will definitely come along and say, oh, guys, remember when I said that building was 40 meters tall? Well, sorry to tell you, it's actually 80 meters tall. And then all I've got to do is go, well, that's no problem, Mr. Client. I'll just make it 80 meters tall. And wait for a little while, have a cup of tea, think about the future, and it regenerates. Yeah. So it's just it's a very flexible way of modeling, but it is constrained. And if it was just all about creating a big blob of space, then I would just use format to get my look. But the great thing about format is I can bring it into Revit then as a mass, and I can append stuff to it. I can use my format model to build the underlying grid to allow me to build a component that goes onto it. That's the great thing about format. Format is like the way in a conceptual way to this being conceptual as well. It's almost the next level of conceptual design. You don't, yeah, exactly. Well, I'm such a cheerleader for format simply because it's a way in for people who find this utterly impenetrable. You know, and I've done this for years and years, and that's the only reason I'm any good at this, because I've done it 1,000 times. But to people who have got deadlines in their lives, you can't expect them to get this straight away. With format, you know, I'm pretty sure I could teach my 4-year-old format. I might even try. You know, so you know what I mean.
Teach me.
But it's that simple. Format is that simple. It really is. Anyway, sorry. To your point about how do I get. I might actually switch. Might actually just end this conversation with that. I'm going to stop the video and just let it process. But because I've done a video online of what you're talking about. But no, I can show you. I can show you.
The only other thing I don't want to ask is going back
Goodbye.
quite a few steps.